Hello everyone, in this video we are going to see about the Karna map simplification using POS, that is product of sums. Last video we have seen about sum of products, all the basics of how to draw the map, fill the map and reduce the Boolean expression. This video we will see about the POS. Generally, the Karna map, also called as a K map, is a graphical representation that provides a systematic method for simplifying the Boolean expressions. Normally, when we have the Boolean expression that is too lengthier, that will lead to complex digital circuits. So we are supposed to simplify the Boolean expressions. For this, Karna map helps. We have from Karna map the variables from 2 to 5. Let us see in this video about the 2, 3 and 4 variable Karna maps. So the 2 variable Karna map has 4 cells, which is 2 power 2, ranging from 0 to 3. And then the 3 variable Karna map has 8 cells, 2 power 3 is equal to 8 and ranging from 0 to 7. And the 4 variable Karna map has 2 power 4, 16 cells, which is 0 to 15. Let us see what is gray coding. Each cell with the K map has a definite place value which is obtained by using an encoding technique known as gray code. Actually, we number the K map in such a way that no two consecutive cells differs by more than one bit. That is called as that is the nature of the gray code. Let us see with an example in the next slides how the gray code varies from one digit to the next digit. The speciality of this code is the fact that the adjacent code values differ only by a single bit. That means when you have the consecutive values of the gray code, they differ only by a single bit. So that is the correct method of numbering the map using this gray code. Only then the simplification will be perfect. That is, if the given code word is 0 1, then the previous and the next code words can be 1 1 or 0 0 in any order, but cannot be 1 0 in any case. Actually, what does it mean is, suppose we have the current position as 0 1, means next will be 1 1 or 0 0. That means this 0 1 and this 1 1, the values changes in one position, which is the MSB, most significant bit. When you consider this 0 1 and 0 0, the values change in the LSB, least significant bit. Okay, so that means here the values differs in between only one position, but it cannot be 1 0. If it is 1 0 means for 0 1 and 1 0, both the positions are changed. 0 is changed to 1 and 1 is changed to 0. That numbering is not possible in the successive positions in the gray code. So when you use the gray code, the successive numbers differ by a single bit. Let us see in the mapping of the drawing the map. Okay, now let us see first the 2 variable Karna map. So this is the arrangement of 2 variable Karna map having 4 cells, and the cells are numbered as 0 1 2 and 3. 0 1 2 and 3, and this is the variables A and B using in this map, and the map should be named as A bar A and then B bar B. Otherwise we can give us 0 1 or 0 1. Actually, the complement numbers represent the 0 value and the original variable represents the 1 value. Okay, so this is the perfect ordering of the numbers and the naming of the cells, which will help to reduce the K map correctly. 2 variable Karna map is drawn for a Boolean expression consisting of 2 variables. The number of cells represent the 2 variable in the K map is 2 power 2 4, and we can draw a map of 2 by 2, which is 1 2 rows and 2 columns, 2 by 2 map to represent the Boolean function of 2 variables. So once the question is given, first you have to look up the question how many variables are there. Accordingly, you have to draw the K map. So this is the these are 2 different ways the map can be represented, either by the variables or by the value of the variables. Let us see the next, the three variable Karnaugh map. The three variable Karnaugh map can be drawn having 8 cells together. Okay, and this map is drawn for a Boolean expression having 3 variables, and the number of cells is 2 power 3, which is 8 cells. So 0, 1, 2, 3, 4, 5, 6, 7. Like this here also 0, 1, 2, 3, 4, 5, 6, 7. This numbering should be done perfectly, and this naming also should be done perfectly. Then only the simplification will be done correctly. So now here, as we seen in the two variable Karnaugh map, instead of this complement position we can use the 0 value, and instead of the original variable we can use the 1 variable. See for here example, b bar z bar in the horizontal line. For b bar z bar, for b bar 1 0 and c bar 1 0, so 0 0. Likewise for b bar is 0 and c is 1, so 0 1. B C both are in the normal form, so 1 1, and B C bar in the complement form, so 0, so 1 0. We can represent either by variable a bar a or with the values 0 1. So having, so three variable column having 8 cells together. So let us see the next one, the 4 variable Karnaugh map. As we know that we are having 4 variables, so we have 2 power 4, 16 cells ranging from 0 to 15. We can draw a map of 4 by 4 variable, and then we can fill the Karnaugh map. So you can see here, we can draw as usual, as you see in the earlier slides. Either we can use the variables or with the values. So we have to remember that the order should be perfectly followed. So we have 16 values from 0 to 15. So how to number the cells? 0 1 2 3. It should not be 2 3, because this is remembered based upon the values of the naming in the Karnaugh map. Suppose for example, take some position, for example 7. What is the value for 7 in digital? 0 1 1. So we can see here the corresponding value is a bar b, and this is cd. For this particular value a bar b is the column row position and cd is the column position. So the values are a bar b and cd. Okay, so now here that is a bar is 0, b is 1, c is 1, d is 1. So 0 1 1 1, that actually the value is 7. So the arrangement of these variables and the numbering of the cells have related meaning together. Okay, so now the same way we can also fill the map using the values 0 0 instead of complement values, and 1 instead of the original values. You can see here for a bar b bar 0 0, for c bar d bar 0 0, for cd 1 1. We can also see here the consecutive cells are differing only by single bit. These successive numbers, first is 0 is same, it changes by 1 bit LSB, and when we consider two of these, LSB is same but the MSB is differing. And likewise when consider these two variables, the LSB is different, 1 0, and MSB is the same. Likewise any successive positions have one difference in the bit value, that is called as an gray coding. Let us see from this given question how to fill the cells. For example, we are given the truth table of this type. So from this truth table we can find out the variable is a 4 variable Karnaugh, because we are having the variables a, b, c and d, and the truth table is given like here. And here the truth table, all the possible values of 2 power 4, which is 0 to 15, is given in the binary values. In the earlier videos I have given the shortcut method on how to write this value from 0 to 15 by heart without making any conversion using the double method. Now these are all the equivalent of decimal equivalent of these values 0 1 2 3 4 etc up to 15. The corresponding binary values are here, and we can see here that there are 3 different outputs. What are the 3 different outputs? 0 1 and x. 0 is given by green and 1 is represented by blue color, and x is represented by the red color. Thus to make the difference they are using different colors to represent the values 0 1 and x. So what you have to do is, once you see the number of variables, you have to draw the respective Karnaugh map. So the corner map is 4 variables. So we have to draw the 4 variable corner map having 16 boxes, and we have to number the corner map as was 0, 1, 2, 3, 4, 5, 6, 7. Then you have to skip the next block. 8 should come here. 8, 9, 10, 11, 12, 13, and 14, 15. So we have remember the naming of this, numbering of the cells will help to fill the values quickly to do the problems properly, fastly. Okay, first up. Now we can see here the values are filled from just they are numbered from 0 to 15. Okay, now so you have drawn the corner map, finding the number of variables, and you have also filled the value positions of the cells in the corner map. Now we got to look into what are all the outputs here. You can see here for 0, 1 and 2 the values are don't care, which is x. What is this don't care condition means? The value may be either 0 or 1 depending upon the necessity. So now for this we are filling as 0, 1, 2. So 0, 1, 2 we have filled with x, and then 3 is 0. So we are putting 3 in the 0 in the 3 position. 4 and 5 are 1. So 4 and 5 are 1. 6 is the 0 position. So this is 0. And then 7 and 8 are 1. So 7 and 8, 1 is filled. And then 9 is 0. Okay, it is filled with for 9. For 9, 0 is filled. Then for 10 and 11, 1, 1. So 10 and 11, 1, 1 is filled. And then for 12, 0 is filled. For 13, there is 1. And then for 14, there is 1. And 15, there is 0 in the given truth table. So based upon the values given in the truth table, we have to fill the cells first. Then you have to go for grouping the adjacent ones. Let us see in the next slide how to pair the or how to make the groups in the given corner map. So now having been filled the values in the corner map, we have to look for the how to group the ones or the zeros. Now we are doing the POS, which is the product of sums. So we have to look for only the 0 positions and not for the 1 values. Okay, so based upon the this truth table given, we have filled all the values whether it is x or 0 or 1. When we start doing the POS simplification, we have to look for only the consecutive zeros in the map. So we have to first always look for the largest group. Okay, there is no big 8 groups are there. Okay, so we have to look for the next smallest group, which is the quad. We know that quad is the consecutive or adjacent ones or adjacent zeros, because we are looking for the POS here. We look for SOP, we have to look for the ones. For POS, we have to look for the zeros. So now considering this column x0x, we know that x can take the value either 0 or 1. So it is called as a don't care condition. If this x helps to form a bigger group or to form any group, we can use the group putting the value of those particular x's 0 or 1 based upon the necessity. Now we are since using the POS, the product of sums, we need to cover the 0 consecutive zeros. So we are using all these x's zeros for now. So continuous 4 zeros make a quad. So that quad is just given in the blue color. Now it is written as quad in the blue color and the value is a plus b. Let us come back how to write the values. First let us see how many groups are there. So group 1, the group quad is covered, and then you have to go for the next any quad is available. No, then you have to go for the pair. Pair is the number of consecutive ones. So here we can see the x here and a 0 is here. When there is a 0, this x can also act as a 0 to make a pair. So we are making a pair, which is the one given in the red color. So one pair is red color, group 2, and then we are grouping this x and this 0 by using the rolling concept of the map. Now we are rolling. When we roll the map, this end and this end coincides to make a pair. So in that way we are making another pair which is given in the red color. So group 3 is formed, which is the red pair. Okay, and then coming to the next one, then there is no pairs are there, then you have to come for the singlets. One zero is here and another zero is here. If that is a zero, just you have to write the cell values as it is, because a single component will not reduce any values. So we have mentioned as singlet as green. There are two singlets we are just giving in the thing, that is the singlet in the green color, and we have two singlets. So in totally in the whole map we are having one quad which is in blue color, two pair which is in the red color, and two singlet which is in the green color. So we have coined all the groups. Five groups are there. Now let us see how to write the equation for this quad, pair and the singlet. As we know, this quad eliminates one variable, and in the case of actually the quad eliminates two variables, pair eliminates one variable, and the singlet eliminates no variable, because we are using the four variable corner map. This is the procedure. So let us see how the equation for this quad blue is written. We have to look for the area the quad is covered. We can see that this is the area the quad is covered, which is the 0 0, and here consecutive zeros 1 zeros 1 and 0 1 are there. They all get cancelled, and no C term or D term will come in the equation. Only the A and B, which is A plus B, because using the POS we have to take everything as a summation. So this is actually A plus B. Okay, so be thorough with the SOP first of all, then we can come to the POS and we to follow. So now for this A, which is a normal term, A plus B, these two terms are available. Then you have to go for the two pairs which are in red color. For this pair encompasses this area. That means here B bar and B is there. For example, for this B variable, this 0 and 1 get cancelled. Only this 0 is possible. So which is actually A. So we have written the value as A. For this pair we have value as A, and then coming to this part, is a vertical part, we have the value as C and D bar. Okay, so we have to just we have to write the for this, actually for this pair we have this 1 0. 1 0 is actually C is 1 and D is C is bar and D is original. Okay, so we have to write as C bar plus D. So here B get cancelled by this, because this is A and B position. 0 and 1 get cancelled, only this is present, which is A. So return as A. Okay, and then in this part C bar and D, because we are using the POS, 1 is in the bar form and 0 is in the normal form. So this is actually C bar plus D. And there are two terms, you have to make it as a combination or the sum of the two terms. Okay, two literals. So this is actually C bar plus D. So A plus, for this area A is remaining, and this area C bar plus D. So A plus C bar plus D is the answer of this pair. Then coming to the next pair, which is this pair which is rolled. This pair covers the area 0 1, which is C D bar. Okay, after that in this area here this B is available in its original form, and A gets cancelled because A is both 0 and 1. So here only B is available. That means the equation for this pair is B plus C plus D bar. B plus C plus D bar. This pair is also over. Coming to the singlet, singlet will not reduce any value. Just you have to write all the terms with the four variables. So how to write, which is the cross section of the two rows and the column. So this column is actually A bar plus B bar, and this is actually C plus D. So the answer is A bar plus B bar plus C plus D. So this is the equation for the singlet. Same way we have one more singlet here which covers the area this and this. So here this is actually A bar and B bar. This is actually C bar and D bar. So it is actually A bar B bar A bar plus B bar plus C bar plus D bar. This is the intersection of this third row and the third column. So the answer is A bar plus B bar plus C bar plus D. So that's all. This is how to convert. First you have to fill the map, then group the form the groups and write the respective groups available, and you have to write the equation for the respective groups. Then we have to join all the terms to find the simplified POS expression. So what is the expression here? You have to sum up all the terms because everything is there in the equation. The quadratic equation plus pair 2 equation and then singlet 5. So 5 terms will be there in the the simplified expression, which is in the product of sum forms. You can see here, this is the sums. A plus B is one sum, B plus Z bar is one sum. So all the 5 terms are sums, but they are multiplied, so it is called as a product of sums. So you have to write the group one by one. The A plus B is written here, then B plus C plus D bar is written here, A plus C bar plus D is written here, and then A bar plus B bar plus C plus D is written here, and finally A bar plus C bar plus C bar plus D is written here. So this all the 5 terms are multiplied, they are the products because we are using the product of the sum terms. So everything is a sum term individually after simplification, and we are getting into the product of the sums. We want to multiply each term. A plus B into B plus C plus D bar into A plus C bar plus D into A bar plus B bar plus C plus D into A bar plus D. Actually what does mean? We are using the product of the sums, which is the POS expression. Likewise, we can simplify any POS or SOP equation. Hope it is easy to follow. Thanks for watching.